Today I'm going to look at continuing the exponent laws that we had talked about in our last video. So again, I'm going to take this here and I'm going to expand and simplify. So inside the brackets we've got 2 times 3, and then that is raised to an exponent of 3. Okay, so you'll remember from our definition of exponents that the exponent, if it is touching that set of brackets, it means everything inside the brackets would be repeated. So this would give me 2 times 3 in one set of brackets times 2 times 3 times 2 times 3. And it's because that 2 times 3 is my base in this expression because it was all contained in the one set of brackets. Now all we're doing is multiplying. And since all we're doing is multiplying, now these brackets, while they keep the bases separate, they don't actually change anything in my order of multiplication. So I can just remove the brackets. And once we remove the brackets, we need to remember that multiplication is what we call commutative. So that means numbers can switch places and it won't change the multiplication. So if I move this 3 and that 2 and they switch spots, I will still have the same answer at the end. So what I'm going to do is I'm going to move all my 2's together and I'm going to move all my 3's together. And then if I've got 2 times 2 times 2, 1, 2, 3, there are 3 of those 2's, so I could rewrite that as 2 with an exponent of 3. And then I also have 3 times 3 times 3. There are 3 of those, so I could rewrite that as 3 cubed. And so what we see here is my product, 2 times 3, when raised to that power, or to that exponent of 3, gives me 2 cubed times 3 cubed. So the exponent really just jumped onto both factors in my product. Okay, let's do another one just to see if it works again. Okay, so we'll do something like, let's say 5 times, I don't know, we'll say 11. And we'll raise that to an exponent of 4. Okay, so my guess is I should probably get 5 with an exponent of 4 times 11 with an exponent of 4. And here's why. Because that exponent of 4, that's a poorly drawn 4, that exponent of 4 is touching the brackets. So everything inside the brackets needs to happen 4 times. I need 4 sets of those brackets. Now, since all I'm doing is multiplying, the brackets can go away. And I get 5 times 11 times 5 times 11 times 5 times 11 times 5 times 11. And now, since multiplication is commutative, I'm allowed to move all my 5's to the front and all my 11's to the back. And that gives me 5 with an exponent of 4 times 11 with an exponent of 4. Okay? Now you might be saying, well, this seems a little bit silly. I wouldn't actually do that. And that's fine. I understand. This exponent law looks a little bit weird until you start actually bringing in coefficients and variables together. Because if I had something like 2 times 3 with an exponent of 3, absolutely, I could solve in the brackets first to get 6. And then I get 6 with an exponent of 3. But it's nice to know that if I have something that has a base that could be split into different factors, so 6 can be written as 2 times 3. So I can change this, instead of being 6 exponent 3, I could write it as my 2 factors for 3, where they both have that same exponent. So it is sometimes beneficial to know that I can split this apart. Okay, now this will come in handy definitely once we're working with coefficients and variables. This exponent law becomes much more important. So this one we have power of a product, and it's when a product is raised to a power, the exponent applies to all factors in that product. Okay, so if I have a product, A times B, and I raise that to an exponent of M, that exponent M will go onto both factors in my product. Okay, now the key to remember is exponents, these laws, because of the equal sign. Normally, we always think of working from left to right, but we are also allowed to go from right to left. Okay, keep that in mind when you go through your assignment this week. I might have something where you have a product and you have the same exponent. You are allowed to then write that as a product inside brackets with that same exponent outside. So you are allowed to move left and right because of that equals sign. Okay? All right, let's look at the next one. Same thing, we'll start off with expanding and simplifying. So again, my exponent of 3 is touching the set of brackets. Since it's touching that set of brackets, everything in the brackets is part of the base, and everything inside the brackets is repeated in this multiplication. Now, since I'm multiplying 2/3 by 2/3 by 2/3, the brackets now don't really do anything. I'm allowed to multiply and divide in whatever order I like, so the brackets could be removed. Okay, and now this really just becomes the multiplication of 2/3 and 2/3 and 2/3. There's no cross-reducing we can do, so my numerator is going to end up becoming 2 times 2 times 2, and my denominator would become 3 times 3 times 3. And we can see that another way of writing that is 2 with an exponent of 3 over 3 with an exponent of 3. Okay, so just like before with our product, we had the exponent jumped onto both factors in the product. Our exponent is jumping onto both the numerator and denominator in our division. Okay, so we do need to keep in mind that we are looking at a quotient, means a division statement. So when a quotient is raised to a power, the exponent moves on to both the dividend, or the numerator, as well as the divisor, which is also referred to as the denominator. Okay, so if I have my quotient, a over b, raised to an exponent of m, and this would be equivalent to having a divided by b raised to an exponent of m. Both would be the same thing. This is going to give me then a with an exponent of m divided by b with an exponent of m, or a with an exponent of m divided by b with an exponent of m. Now the one caveat here, we have to make sure that our base b is not 0 because we can't be dividing by 0. That does not work. Okay, so that's our power of a quotient law. And you can probably see that the power of product and the power of a quotient, they're very similar. Just like before when we had our product law and our quotient law, they were very similar as well. Okay. The last one we're going to talk about in this video, if I had something like this, if I have 2 with an exponent of 3 in my set of brackets, and then it's raised to another exponent. So I have a power that's raised to another exponent outside the set of brackets. Okay. So let's look at this. We'll break it down. So this one, the 2 exponent 3, that exponent of 3 is touching the 2 directly. Okay, so that means inside the brackets I have 2 times 2 times 2. And then I still have that exponent of 2 outside. And then now I have that exponent of 2 is touching the brackets. And so everything inside the brackets is going to be repeated. So I'm going to have 2 sets of that set of brackets. So I get 2 times 2 times 2, or sorry, 2 times 2 times 2 times 2 times 2 times 2. And these brackets don't do anything now. I can remove the brackets since all that's happening is multiplying. And when I remove the brackets, I'm multiplying a whole bunch of 2's together. There are now 6 of them all together. Okay? And you might notice that, well, my exponent of 3 and 2, 3 times 2, gives me that 6. If I multiply my 2 exponents together, I get that exponent of 6. Let's see, we'll test another one to see if that holds for something else. Let's try another. We'll pick a different base. Let's go 3. We'll go exponent of, let's say, I don't want to write out too many things, and I know you don't want to watch me write out too many things either. We'll say 3 exponent 2, and then we'll say to an exponent of 4. So that's going to be 3 times 3 inside the set of brackets, and then raised to an exponent of 4. So that would be 3 times 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 3. I have 4 groups of that base that's in brackets. And then I remove the brackets, leaving me with 8 3's in total. And that's good because my guess was, well, I should be able to multiply my 2 exponents together, and 2 times 4 does give me 8. Okay, so our 5th exponent law that we have now is a power of a power, and it's when a power is raised to, I should say, an exponent. when a power is raised to an exponent, the base remains the same and the exponents multiply. Okay, so if we have a power, a exponent m, raised to another exponent, we'll say n, the base stays the same, so it stays as a, but the exponents then multiply together. Okay, all right, there we go. We've got our first 5 exponent laws. We'll talk about the next one in our next video.